Right, so we're going to do question 16 on AQA's paper 1 2021. First thing, part 1 is quite a bit more difficult in my opinion than the other two parts, but I really don't think it should be worth 3 marks, it should be worth like 4 or 5 marks, but well, we have to firm what we're given. I'm probably doing it a longer way, that's why, but my way definitely works. So we've got y equals, we've got this equation right here, e to the minus x sine x, and the question is asking, find the exact value of the area A1. Given A1 is right here, it's hiding behind my little scribbles. And this graph, I'm not gonna lie, looks a little bit weird. It looks a little bit weird, it wiggles, and then the wiggles go smaller. But you don't really have to worry about that. You just have to worry about when y equals 0. So these 2 points right here. So obviously, let's write the equation when y equals 0. Now, we've got 2 different things right here with variables in them. Sine x can equal 0, right here. But e to the minus x, same as writing 1 over e to the x, cannot equal 0, and it's actually always greater than 0. That's going to be something that you have to remember, to be fair, is like anything to the power minus x is just always going to be greater than 0, because no matter what x you put in there, whether it's like 2 or minus 2 or whatever, like e to the 2 is just a fraction, but that's greater than 0, so, and e to the minus 2 just means that you're going to flip that back up there, so you just got e squared, and that's obviously bigger than 0. So that's just a little fact that you have to remember. So that means we can divide by this e to the minus x and basically only focus on this sine x. So we divide by e to the minus x, whatever. It just disappears in the end. So now focus on sine x equals 0, and should be common. No, you should have drilled it into your head really by A level, but when sine x equals 0, x equals 0. Let's write in radians because it'll probably be easier, and then pi, just basically all the pi's that you can ever think of, every single pi. But for now, we're just going to be thinking of 0 to pi because it's obviously going to be the first point right there where it hits 0. So let's set out our equation. We're talking about area, integration. Let's set the limits. We want to integrate the equation we've been given. We've got the dx. This looks like a integration by parts, because we've got an exponential here, and we've got a trig. Like that, doing that by substitution is not going to be great. So let's do it by parts. Obviously, remember your acronym LATE. I cannot spell latter. LATE. So we've got logs, algebra, trig, exponentials. So to differentiate, trig becomes is before exponential. So let's stick that right there. So then u dash equals cos x, and then v dash, which is just a derivative of v, or like dv over dx. So v dash equals e to the minus x, and when integrating e to the minus x, it's honestly just the same as differentiating e to the minus x, because it's a minus 1 in front of the x. So if you want to be dividing by the power, it's just putting a minus in front of it. So there we go. We'll do the equation of the by parts is u times v minus the integral of u dash v. So let's make this equal to minus e x, which is v, times sine x, which is u, minus the integration of u dash, which is cos x, don't forget a dx at the end here, and then v. But we've got a minus right here, so we can actually turn that into a plus in front of the integral sign, because you can take out a minus, and then there we go. Oh, this doesn't look very good, is what you might be saying. But if you just carry on with it, now let's focus on just this part. This part's already solved pretty much. Focus on just that part. We've got, again, the same thing, u equals cos x, and then u prime equals minus sine x. Then v dash equals e to the minus x, and then v equals minus e to the minus x. Again, using the same equation, don't forget about this minus e, and don't forget about that basically. Write that down first. Then we're going to have a minus somewhere in it. Yeah, we've got a minus, so we're not going to write plus, we're going to write minus first, because this is minus e to the minus x. So uv right there, and then minus the integral of u dash v. So it's minus sine times minus e to the minus x. So them minuses cancel out right there, and we just get an e to the minus x sine x dx. You might be thinking, oh, what? We're just going in loops here. Like, what? Can't do that, mate. Well, the thing is, I don't know if you've forgotten or not, but we have got this thing at the beginning. Right here. So we're practically saying now that this equals all of this, and this is going to go on forever. But, as you can see here, these are actually the same things. So what we're going to do is we're just going to move this over that side. So we're going to have 2 of this equal to, let's take out a factor of this, e to the minus e to the minus x, sine x plus cos x. And then we can just divide everything by 2. And obviously we need the limits. And now we can just sub everything in and stick it in the calculator. And in the end, we will get e to the minus pi plus 1 over 2. That's for the first part. See what I mean by 3 marks? Not very generous for that first part. Let's go on to the second part though. This is quite easy. So first thing is, because it'll be easier if you've actually got it on paper, but I don't have it on some tablet. Let's just redraw the graph so we remember it. Something like that. A2, A1. So we want to focus mainly on A2 now this time, because we've already figured out A1. So we've got these 2 points here. It's going to be the same integration equation that we've just come up with right here. Right here. So we just stick with that. I'm actually going to copy and paste it because I cannot be bothered writing it out again. A little bit of laziness from me. So there we go. But we will have different limits, because instead of it being from 0 right here, it's going to be from pi, which this first one ended, and then to 2 pi, because remember the x is when you get sine x. Just is every pi, every single pi. So let's do 2 pi at the top and pi at the bottom right there. Subbing all of this in. I'm just going to write out initially. Oh, not sin x. Sin 2 pi plus cos 2 pi minus, let's put another bit of brackets around them. Oh, e, that's not right. E to the minus 2, oh not 2. Oh my, how many mistakes am I going to do? Over 2 sin pi plus cos pi. So, with experience, you'll kind of get used to knowing like what sin pi equals to and cos pi equals to. But it's better just to look at a graph really. You've already sort of got a sine graph here. So when we got sin pi it equals 0. Right here, it's along the y equals 0 line. So this sin pi and this sin 2 pi both can equal 0. So we can basically just write 0 in both of them. And instead, now we've got, wait, I forgot a minus there. The cos pi. And cos pi is a bit of an opposite graph. And that starts at 1 and goes on to minus 1. And at pi equals minus 1. And at 0 equals 1. So it's basically the opposite. And at 2 pi equals 1 again. So we've got a 2 pi right here. We've got a pi right here. So one of them is obviously going to be minus 1. Right here. Actually, not the 2 pi one. So the minus 1 will help us out with this minus right here and it will cancel. So let's just start writing things down because I'm kind of waffling a little bit too long here. E minus e to the minus 2 pi over 2 times by cos 2 pi, which is 1, minus, remember that these minuses are going to cancel out. Just going to get minus e to the minus pi over 2 times by 1 again. So we can take a factor. So actually it was right, yeah. We can take a factor of e to the minus pi out of here. And then we're left with e to the minus pi from here minus 1 over 2. Obviously don't forget the minus. Oh, probably need to separate them. And that's A2. That's what A2 is equal to. So we need to figure out what A2 over A1 is. So we've got minus e to that. All of this right here over A1, which was kind of like forgotten. Ah, it's just the same without a minus. So we've got that's right there. Okay. Hold on, what have we done here? This doesn't look great. No, we've got a plus 1 right there. Not bad. So this is a plus 1. Ah, okay, yeah. Take the minus back in. Take the minus back in. And we can just change. Yeah, we can change. I think. Yeah, because that'll be plus 1. Okay, I was just a bit silly from the beginning. Yeah. It'll be plus 1 because you're taking this minus away. Okay, so now we're fully cancelling both of these and you get the final answer. Jeez, that took a bit of reconsidering what I was doing there. And then question 3 is this one, I'm not gonna lie, takes a bit of imagination. So we've got to recognise that the areas make a geometric series. So we've got A in a geometric series as the first term, and in our case the first term is this whole area right here, and obviously this is the second term. And R, because we want the as the series goes to infinity, because obviously this is going to infinity, isn't it? So A over 1 minus R. We've been given an R right here from our last question, sort of, but we also got given it in this equation. So we've got R equals that, because R is the common difference, and it's showing the difference between two separate areas here, if you understand what I'm saying. Like, so for us it was A1 and then A1 plus 1, which is A2, but it's saying that given that any consecutive areas, their common difference will always be this. So we've got R equals e to the minus R. We've got A equals our first term, which was e to the minus pi plus 1 over 2. And basically just do this, s to the infinity. A being this. Oh, I cannot. There we go. A being this, and then times 1 over 1 minus R right here. So we've got e to the minus pi plus 1 over 2 1 minus e to the minus pi. It doesn't quite look like what we need yet, so let's rearrange these e to the minus pi's. 1 plus 1 over e to the pi. We've got 2 1 minus 1 over e to the pi. And what we can make that then equal to is if we times up this, we get a 2 e to the pi minus 1. And then if we times up this, we get an e to the pi plus 1. And then there you go. Got the final answer. Now, see what I mean by the last two questions were much simpler than the first one. I had a little bit of a brain stumble on the second part, but yeah, the first part was definitely the most rigorous one. Okay.